The next set of instruction we are going to be looking at is the positive signal edge and the negative signal edge. So the positive edge signal, it's all in English at the end of the day. Okay, so positive signal edge and negative signal edge. Okay, so we call these instructions generally, we call them edge detection, let's say instruction, edge detection instruction. Okay, so for your positive edge signal or positive signal edge, what it's looking for is the state of transition from signal state 0 to 1. Okay, so if your signal is transiting from 0 to 1, you will have an RLO of 1 if you are using a positive signal edge. What am I trying to say? Let's say you have a push button. Okay, when you are trying to when you press the push button, that moment where that contact is made, that particular moment when that contact is made, that is, the signal is going from that 0 to 1, is what you call the positive edge signal. Okay, so when you have something like this, you know, this is state of 0, this is state of 1. The point where this guy is transiting from 0 to 1, this point is the positive edge. Okay, so that is positive edge. We also call it rising pulse. In some other PLC, you can see them using rising pulse. Okay, so you can now see something like this as the symbol, an arrow pointing up, rising pulse. Okay, so but for the negative edge signal, the reverse is the case. Okay, so negative edge signal, take note of the transition from signal state 1 to 0. Okay, so when your signal is transiting from 1 to 0, your RLO will be 1. This is transiting from what? From 1 to 0. So it's trying to transit. So at this point, okay, at this point, what you have is the what? The falling pulse. It's also represented this way in some PLC program. Yes. The RLO is 1. Just that one is taking note of transition from 0 to 1. The other is taking note of transition from 1 to 0. Let's see it in our PLC program so we can understand better. So let's experiment the positive and negative edge. Okay, so let's say this is a positive and this is the negative. Sorry, I selected the wrong one. So I'm using I I10.0 here. Let me use M0.2. I will still use I10.0. Okay, let me use M0.4. So I can use M0.3. Sorry, let me put memory here. M0.5. Let's use it this way. Okay. So let's compile and download to the PLC. So take note. Please, let's take note of how this work. Though I will do some setting of the output later so that we can be able to see it working. But let's focus our attention on the board for now. Okay, so let's see how M0.2 will behave. Put your eye on M0.2 for now. Okay, so M0.2, now you observe something that you cannot see the effect, right? That's simply because the rising force, the edge detection is so fast that it could be difficult to notice. Okay, so what we are going to do now is we will see that our M0.2, instead of using the normal output instruction, we are going to use the set instruction at this point. So let's go offline. So I will change this to the set instruction. Okay, I will change this to the set as well. All right, so compile and load. So again, focus your attention on M0 dot what? Dot 2. So can you see? It is set. Okay, it is set. Now let's focus our attention on M0.3. Okay, now you notice that, okay, it has been set now. You notice that the M0.3 only had to come on when there is no longer signal in 10.0. Okay, which explains that for your falling pulse or your negative edge signal, what it's taking note is the transition from the state of 1 to what? To 0. While on the other hand, your positive edge is taking note of signal state of 1 to what? To 0. You recall that the first time when we tried to simulate it with the normal output instruction, we could not see any effect. That's because the only thing that the edge detections are taking note of is the transition, the state of transition from 1 to 0 or from what? 0 to 1. So they don't care whether it is on or off. What they care is, okay, it is turning on or it is turning off. Are you getting it? So for any application, for any reason we need that particular signal of theirs, we can now try to store it or retain it. That's why we try to use the set instruction here, so we can hold on to the signal, the RLO of 1 that they supply us. Do we get it? So just for the purpose of the class discussion, in what application do you think this positive edge or negative edge can be of use?